So, like over a year ago now, I made a video on the 16th century astronomer Tycho Brahe for my Badasses in the History of Science series. And there was a great story that I really wanted to include in that video, but I couldn't really make it fit because it's not really about Brahe per se. It's actually more about his contemporaries Johannes Kepler and Galileo Galilei. So after way too much delaying, I've decided I'm finally actually going to make a follow-up video to tell that story on its own. Okay, so it's 1610, and Galileo has recently repurposed the nautical spyglass into a telescope, thereby creating the most powerful astronomical tool the planet had ever seen. Galileo's telescope achieved a 30 times magnification, a full order of magnitude stronger than anything that had come before it. Astronomers the world over were reading about Galileo's device and the observations he was making with it, and anticipation, unlike anything the scientific world had ever known, filled the air. Everyone wanted to get their hands on one of these things to see what they could see. Hundreds, maybe even thousands of astronomical controversies were about to be settled once and for all. One of the big controversies was how many moons Mars has. You can see the red planet with your own bare eyes, of course, but you can't see its moons. It had long been speculated that Mars, like Earth, had its own satellites, but up to that point, speculation was pretty much all they had to go on. And no one had more writing on their speculation than Johannes Kepler. He had a theory that God had arranged the solar system as a series of circumscribed platonic solids. Upon learning that Jupiter had 4 moons, Kepler hypothesized that Mars must have 2. You get the Earth had 1, Jupiter had 4, so 2 would be the number needed to balance the divine cosmogony. But even in Kepler's day, speculation wasn't evidence. So when Kepler received a coded message from Galileo about moons, Kepler hoped that Galileo may have just proven his hypothesis. Wait, hold on a sec. What was that about a coded message? What the hell? Why didn't Galileo just tell Kepler what he found? Turns out this was actually a fairly common scientific practice at the time. Imagine for a moment that you're a scientist who has reason to believe that you've solved the mystery, but you're not quite 100% sure yet. What do? If you wait too long, another scientist might scoop you and steal your glory. But if you go out on a limb and you're proven wrong, then you're humiliated in your colleagues' eyes. The solution? Encode your hypothesis and send it to one of your colleagues. That way, you can wait until you find sufficient proof to lift the veil. If someone else comes along and tries to lay claim to your discovery, you can give your colleagues the cipher, and that will prove that you got there first. It was a great strategy. The only problem in Galileo's case is that Kepler was actually a pretty damn good cryptanalyst. When he got the encoded message, he decided to not wait until Galileo gave him the cipher, but instead got straight to work trying to break the code, and break it he did! When he deciphered the text, Kepler read that Galileo discovered Mars did indeed have 2 moons. Galileo's telescope had vindicated Kepler's theory. Only it didn't. In fact, it would take more than 250 years worth of improvements in telescopy and tools hundreds of times more powerful than Galileo's before anyone ever laid their eyes on the moons of Mars. So what then did Galileo's message actually say? Well, it was about moons. Kepler got that right. It just wasn't Martian moons. Galileo's message actually said that he had found 2 moons orbiting Saturn, not Mars. But of course, we know today that Kepler was actually right. Mars does indeed have 2 moons, Phobos and Deimos. So for a few months at least, in 1610, Johannes Kepler was the only human being on the planet that could honestly say he knew how many moons Mars had, and he would be the only person to know that fact for a quarter of a millennia. Or then again, did he actually know this fact? As it turns out, this is a question that has caused deep divisions among epistemologists for the last half-century. For most of Western history, the dominant theory of knowledge was Plato's justified true belief theory. According to this theory, one can only properly claim to know something if A, they believe it, B, that belief is justified, and C, that belief is true. It's not enough to have 2 of the 3 or 1 of the 3. You need all 3, according to Plato. A justified but false belief isn't knowledge. A true belief that's just a lucky guess isn't knowledge. And a justified true claim that isn't believed isn't knowledge. This account seems so unimpeachable to most people that no one really questioned it for over 2,300 years. Until, that is, the American philosopher Edmund Gettier published a 3-page paper that completely upended the discipline. That paper was called Is Justified True Belief Knowledge? And in it, Gettier lays out a program for producing what seem to be counterexamples to Plato's theory. For example, this is one of the ones that he uses in his paper. Imagine that you're watching TV and you see John McEnroe win the Wimbledon tennis champion. You would then have a justified belief that McEnroe is the current Wimbledon champion. But unbeknownst to you, the match you just saw on TV was actually a recording of last year's championship. Yet it just so turns out that McEnroe did win again this year, so he's still the current Wimbledon champion. So in addition to being justified, your belief is also true. So you have all 3 ingredients for Plato to say you have knowledge. But according to Gettier, even though you have a justified true belief, you do not have knowledge. I hope you can see, based on this example, how easy it is to generate these so-called Gettier cases. Cases where all 3 key ingredients are present, but where the person doesn't seem to have knowledge. A whole cottage industry sprang up wherein philosophers started coming up with dozens and dozens of Gettier cases. And the case of Kepler believing that Mars had 2 moons seems to fit this mold just perfectly. So if your reaction a few minutes ago when I said Kepler knew Mars had 2 moons was to say, bullshit, he did, congratulations, you have felt the force of the Gettier intuition. After Gettier published his paper in 1963, philosophers scrambled to figure out how to respond to the Gettier problem. Some tried to salvage Plato's theory in several different ways, others tried to come up with new accounts from scratch, but there was a general agreement that Gettier had succeeded in undermining Plato's overly simplistic account of knowledge. Or did he? In 2001, epistemology was thrown for another loop when Jonathan Weinberg, Sean Nichols, and Stephen Stitch published a paper detailing the results of a massive cross-cultural study showing that not everybody shared Gettier's intuitions about these cases. Specifically, while Western educated people almost all seem to share the Gettier intuition, people from East Asia do not. That is, people in East Asia would hear the story about watching McEnroe win at last year's Wimbledon, or Kepler deciphering Galileo's message and say, yeah, that counts as knowledge. Sure, why not? This is a rather striking finding. Western philosophers had sort of just assumed that everyone shared the Gettier intuition, because after all, they'd been talking to each other, and everyone they'd been talking to shared the Gettier intuition, so they just sort of generalized from that obviously now highly biased and unrepresentative sample set to the world as a whole. But if epistemic intuitions in fact vary by culture, then we need to be much more circumspect when appealing to those intuitions as evidence to resolve epistemic problems. And bizarrely enough, people from East Asian cultures seem more likely to adhere to Plato's theory of knowledge than Plato's actual intellectual descendants in the West. Or are they? Okay, you're probably sick of me doing that by now. I'm sorry, but there are a lot of twists in the story. That's the last one. I'm done, I promise. Over the last few years, since Weinberg, Nichols, and Stitch published their paper, there have been several attempts to replicate their experimental findings, and they've all pretty much failed. The exact reasons for this are complicated, and it's tied up with a very pervasive replication crisis in the social sciences, but that's a topic for another video on another day. But I do think it's important to stress that there was no fraud or malpractice involved on Weinberg, Nichols, and Stitch's part. It just turns out that science today, as in Galileo and Kepler's day, is really, really hard. All scientists, natural or social, are trying to decode the messages they receive. And no matter how good we are at code breaking, even the best of us is going to get it wrong, and probably more often than we get it right. But every once in a while, you can hope that maybe, like Kepler, we will, even if we err in our attempts at deciphering, we'll somehow get it right anyway. Stop gazing, you crying blue. I mean, seriously, how the hell, right? Science isn't just hard, man. It's weird, too. Anything